contractors. We're actually the prime contractor. And this past April, I had the opportunity to fly in the KC-135 as a mentor for some high school students who were from Region 8 in Texas, which is right about here near Texarkana, near the Arkansas border. This is a program called the Texas Fly High program, and what this program will do is continue to fly high school students on the KC-135 so that they can get real experience about what science and engineering is really like and how to do research. During the odd numbered years, like this one, they'll take the eastern part of the state, and during the even numbered years, they'll take the western part of the state. The region I was involved in picked students from 3 different schools. We had a total of 12 students involved, and they were from Chisholm High School, Pittsburgh, and Sausalito. And after this, you'll be experts on the KC-135 because this is just a brief review about what the other gentleman spoke about before, the KC-135 and how it flies. KC-135 is used to simulate microgravity. It flies up 45 degrees, flies a parabola down at 45 degrees, and on the downward slant, you experience microgravity because the plane is flying faster than gravity. We have about 40 parabolas. During our first flight, all the students got motion sick just about, so we turned around earlier and did about 30 parabolas. We usually do about 40 parabolas. Microgravity lasts for about 30 seconds, and the total flight lasts about 2 hours. People's physical responses vary. Some people can take it well. I managed not to get sick, fortunately, but some people get sick, and very few people get sick to the point of misery. But a lot of people were sick on this flight, but after it was over, they recovered, and you have the option of taking some anti-nausea medication, which I chose to do. This is what the inside of the KC-135 looks like. I'm an engineer, but I chose to do some medical experiments. We did blood pressure, pulse, and reflexes, just something simple because I wanted to teach the students more how to do experiments, how to get adapted to microgravity as opposed to getting in depth about the medical knowledge. But I found that doing this, what seemed to be a simple experiment, turned out to be a little bit complicated in microgravity. This is what the inside of the KC-135 looks like. The walls are padded so that you don't hurt yourself because in zero gravity, everything goes zero G if it's not nailed down. People, equipment, and then you just get float up against the walls, and no one was hurt, but you just have to be really careful. Now this isn't sunlight. These are this is indoor. This is lights inside the plane. They're covered. They used to not be covered, but that can be dangerous. So they're covered up. Everything's padded well. And if you'll notice on the floor, about every 5 feet or so, 5 to 10 feet, there are places where you can bolt things down. So this aircraft works for many different experiments, and you can configure it to however you need. We had a little corner probably to the back and over here behind where the gentleman is standing, but you'll see those pictures later. Now, how do you get an experiment approved to fly in the KC-135? That I think was very interesting because I'd heard about the vomit comet, as everyone calls it, but what does it take to fly an experiment on the KC-135? And as it turns out, there's a lot involved. The KC-135 isn't an experimental aircraft, but it's very, very safe. But again, there are a lot of things you need to do before a person is allowed to fly or equipment is allowed to fly aboard the KC-135. Just to talk about the equipment, if anything was going to be bolted to the floor, it had to have a stress analysis. I didn't need one because we were using human subjects. Nothing was being attached to this aircraft. Otherwise, I would have had to pull it with a strain gauge to see if it could, survive that. A hazard analysis. As mentors, we sat down and we had a meeting, and they basically explained what types of experiments would be allowed. We could choose an experiment we wanted to do, or we could allow the schools to do their own. But they said, warning, if it explodes or if it's a projectile, it's not allowed. The whole idea is to be extremely safe. And the day before we flew, there was something called a TRR, where the flight coordinators actually looked at the equipment, gave suggestions for how it might work in microgravity, but they had to approve and see and physically touch anything that went aboard the plane. So it was it was very rigorous getting equipment approved and paperwork needed to be turned in various intervals. I had to undergo what's called an IRB human review board because we were using human subjects. We were doing things as simple as blood pressure, reflexes, eye-hand coordination, and taking the pulse. But again, there was a room full of medical people, and they just basically asked if they had any last questions. This experiment passed easily. It wasn't invasive at all, but still, everything is very, very regimented. As far as allowing people to fly in the KC-135, I had to take a physical. I'm now eligible to fly in the KC-135 for about 2 to 3 years because I passed the physical. One of the physicals, they do take a chest x-ray. They want to make sure there are no bubbles in your lungs. They're very, very careful about things like that. I also had to undergo what we call physiological training, and I got to fly in a hyperbaric chamber. They call it a chamber ride, but it doesn't ride anywhere. It doesn't fly. It's just a cement chamber on the ground, which brings you up to about 25,000 feet and lets you experience what the air is like at 25,000 feet. So we sat in a chamber, and that's one of my students at the very end. We sat in a chamber. First of all, we had about 7 hours of lecture. We sat in a chamber, put on a mask, which I found did not fit well, so it was a lot to get acquainted with. But you put on a mask and you breathe oxygen. You breathe pure oxygen for a while, and then you breathe normal oxygen. And then the chamber decompresses, and at some point in time, you're told to take off your mask. And the purpose of this experiment is to know what it feels like when you're not getting enough air. So if by chance the KC-135 did blow a hole and we were losing pressure, we would be able to tell them, we'd be able to be aware. They wanted us to feel what the symptoms of hypoxia are like, which is basically oxygen deprivation. We were handed a sheet of paper and asked very simple questions. What is your name, your numbers? And then as time goes by, it gets harder to answer these questions. As soon as I felt oxygen deprived, I put my mask on. The point of this experiment is not to be Superman or Superwoman and see if you can get delirious, but to recognize a symptom so that we realize what it's like. So I put my mask on as soon as possible, but there was someone to the right of me who I guess thought maybe he could take a little bit more, but you could clearly see what it looked like when someone was hypoxiated, very delirious, hard to talk to. It was just very, very interesting, but this is what the inside of the chamber looks like, and that's at the Sunny Carter here.
They have someone in the chamber in case someone passes out.
Yes.
With a mask on.
There were about 2 people in the chamber who kept their mask on. Everyone was very experienced, so they kept their masks on. There were people outside, there was someone operating the chamber, so there were 2 people, and they told us, if you don't put your mask on and we think you're hypoxiated, we will put it on for you. So no one was hurt, but it was just a good experience. Like I said, I did blood pressure measurements, and this is just what some of my data looks like, but it was very inconclusive because the environment was so unique that it was difficult to take measurements. Just something as simple as taking a blood pressure measurement became extremely difficult. This is what taking blood pressure on a KC-135 is like. The person on my right is taking my blood pressure, and that's a teacher on the left who also flew with us. He's taking my pulse. The second ride, we learned a little bit more. People keep busy, they're less likely to get sick, in my opinion. The teacher who is right here became extremely ill the first day. He was just sitting still, concentrating on not moving his head. He began to perspire, had to be taken to the back of the aircraft, and there's a doctor on board. But the second day, he was fine. He learned how to just to get busy right away. And that's one thing I think was just a learning experience in and of itself. How do you operate? Okay, so as we see, we're about to enter microgravity, and there are leg restraints. This is all that's carrying us to the bottom of the craft. As you see, there's a teacher there about to lift up. Her feet are just about lifting off the floor. So 3 of us are sharing one leg restraint, and we're taking blood pressure. But there was a time where we lost the leg restraint, and on the first flight we damaged the blood pressure cuff, so our data, we couldn't take any more blood pressure data. Also, the student who was the subject became ill. So if she's ill, then that's going to affect her measurements, and all these things that that shouldn't seem very complicated now become complicated. We also did eye-hand coordination, just something simple. We learned that you do get disoriented in microgravity, it's hard, but there's a student, that's when we're in 0G. Someone had to position me so I could take his eye-hand coordination. We could have chosen to sit in the seats, which are located in the back of the aircraft, but I felt like I wanted to, let's see what 0G is like. We're being bolted down to the chair. In fact, our data, I want to experience what is it like, how do you maneuver in zero gravity? So we chose to have like free flight, and that complicates taking measurements. See, I have the blood pressure cuff, which as soon as you it banged around a little bit, and then you have periods of 0G, but after 0G, you go down into 2G. So there's a point where we're all just laying flat on the floor, you can't move, you have to write down your data either before or after that period. And what would happen is I'd get a piece of data, I'd have to remember it because it was nearly impossible to write it down. So if I had to redo this experiment, I would have a tape recording device where I'm talking through it. I would have computers take as much data as possible. If by chance you can hook up, a blood pressure device to a computer, because I think that would be the most accurate. Our data also is inconclusive because we have to determine, what's going on at the point where this data is being taken. Are we actually at 0G? Are we going through a 2G period? It just became very complicated, so you need more data to be accurate. Reflexes were a little bit easier than taking blood pressure. You had to be very, very quick taking blood pressure, but reflexes, you'll see, I'm just sitting under a leg restraint. That's Dr. Yvonne Cagle on the left. She's one of the astronauts. She mentored me as I mentored the students, and told me a lot about a lot of the medical information on it. So I'm sitting there, I'm getting my reflexes taken, which are normally very stiff, but in 0G they're very easy. But again, just something as complicated, I had to force myself to stay on the ground with my left leg while I let the other one flow freely. Again, this is the second flight, the second day of flying. We flew the experiment twice, and I'm taking the teacher's reflexes. And again, it was coordination. We're all sharing one leg restraint, and as you can see, people are floating about the cockpit, so you need to concentrate on where you are and make sure that you're not bumping into someone else's experiment. So I thought that was pretty interesting. The one leg restraint worked well for us because I wanted to actually take data as we were in 0G, so I wanted to be able to float. And again, our blood pressure data. The systolic pressure seemed to be decreasing, but then it increases again. So I felt like I didn't have enough data points. I was the subject for the second day. The first day we had a student carry, and again, we were only able to take 2 measurements. So I thought that wasn't very conclusive. So we can see by when the systolic pressure starts to decrease that more stimulus are taking place. But again, I don't think this is enough data to really draw conclusions on. I think that what I learned from this experiment was how to do another experiment on the KC-135. But I think that was really good because I know physically what I felt like and how that affected us. Again, we were a part of the student flight campaign. The program was run by Dr. Don Sikores and Dr. Bert Ford. The whole purpose of the experiment was not necessarily to gather a whole lot of data, but to get the students acclimated to microgravity, what's going on. And they found out that this was the second year that they did the program, and they found that students learn more about teamwork and working together and coordination than they do any other. Like, those things are just as important as learning how to do the scientific data. Our school was very up to date. I communicated with students over the internet. Just a few days ago, I spoke to another student as he was writing a final report. So we had the privilege of being able to communicate via email. They were very up to date, but other students have more of a challenge where there is no email. That's something else to teach the students. How do you make a project like this work? But there is a college program which flies students twice a year, and the high school component has just started. They had the pilot program in 1998, and this year, 1999, they had 17 teams and 8 flight students. So I really had I had a very educational experience and a fun experience being a mentor, and I learned a lot about, microgravity, how does it work, and how complicated, but challenging in a fun way it'll be to work aboard a space station when you have zero G and what goes into it. So I think I have a better understanding of it, and my students do as well. I think they can put, rather than just having NASA on TV, I think this project brought it home to them. But are there any questions?
The students kind of approach it like all zero G is old fashioned. We know all about it, but once they go through the program, have a different feel about the whole thing.
I don't think my students quite knew what to expect. We told them about the KC-135. We showed them the picture of the parabola, but I got a videotape of it afterwards. I don't think it's until people actually see the pictures and they see the floating that it actually comes down to home. With my students, it was like, we're doing a project, but they didn't quite know what to expect or what was going on. It was a NASA program, and I explained it, but I don't really, I think when people see the pictures that they'll really get it. I had two student flyers that flew the first day, but they got ill, and one of them could have reflown, but they opted not to. So I think they enjoyed it, but they learned a little bit about the practicality of it. They recovered quickly, and one student even commented, I fly again next week, but just not quite so soon. So they all got a little bit of a dose of reality, like, this is work. But I think they really enjoyed it. They gave presentations afterwards to the Lions Club, the Kiwanis Club, the school board, and we had 4 students fly, but there were 8 students on the ground, and we didn't just want the students on the ground, twiddling their thumbs, and we wanted them to be an active part of the team, just like with NASA, it's not just the people who go up in space that are part of the program, but people on the ground as well. So the ground team were assigned jobs, some publicity, one to write the report afterwards. They each had jobs, and we're compiling our information. We took lots of digital photos. We're compiling that information for future use. So the ground crew had a job to do later, and that's something, if I got the opportunity to fly next time around, I would definitely keep the ground, active and